Welcome, Coach Eichner's Math. Today we're going to talk about properties of a rectangle. Rectangles are going to follow the same properties as parallelograms. They're a special type. What that means is your first 5 properties that we've talked about with parallelograms are always going to be true for rectangles. We've added the 2 properties that 4 right angles are always going to be in my rectangle and that my diagonals are congruent for a rectangle. These are true for a rectangle, but not always true for a parallelogram. And that's why it's important we know what type of shape we're dealing with as we are working through our problems. So let's go ahead and apply these rules down to problem number 1. I'm going to go ahead and make it a little bigger for us. First things first, opposite sides are congruent. So right now I know that PQ and SR are opposite sides, so I'm going to go ahead and mark SR as 24. And I'm going to go ahead and mark QR as 10. That's the easy piece of this. What you're going to have to look at next is the fact that we have a right triangle. I'm going to use my new property to tell me that that's my right angle. I'm going to have a right triangle right there, and we're going to use Pythagorean's theorem, which, just a real quick reminder, you have A, B, and C. So you would say A squared, 10 squared, plus B squared, 24 squared, equals C squared. So as you're doing this, easiest thing to go ahead and do is type it in your calculator. Put this down right here in front of you, and I'm going to say 10, let me clear it out, 10 squared plus 24 squared. Take that, that's 676 is C squared. 676 equals C squared. And then I want C, so I'm going to take the square root of both sides. So for those of you who need help with finding that, in order to go square root, I'm going to hit the second button, and then I'm going to come right down here to the x squared, and I'm going to hit the square root. Notice it'll open up a square box, and we're going to type in 676, and that is 26. So the purpose of doing that is now I know that my diagonal, SQ, is 26. PR is my other diagonal. My second new property tells me that diagonals are congruent, so PR would also be 26. And then QT would be half. Now, because it's a parallelogram, I can jump back up here to where it says diagonals bisect each other. That would apply here. So 26 divided by 2 would tell me that QT would be 13. My suggestion at this time would be for you to pause the video for just a minute and go ahead and try problem 2, and then come back and check how you did. Welcome back. Hopefully you looked at it and you said that we know that we have a bisector with our diagonals, so this piece would be 15, ED would also be 15, and EB would also be 15. Because diagonals are not only bisected, but for a rectangle they are also congruent. We know that DC and AB are opposite, so that makes AB 27. Let's go see what we filled in. We know AB is 27. BC we need to find still. We'll use Pythagorean's theorem. BE is 15. BD is that whole diagonal, which would be 30. And AC would be this whole diagonal, which would again be 30, because diagonals are congruent. So to find BC, we go ahead and pull out a different color here. We're looking for BC, and we know that we have 4 right angles, which tells me I've got a triangle here, and I can say A and B and C, and say A squared, 27 squared, plus B squared, I don't know B yet, so B squared, equals 30 squared, or B squared equals 30 squared minus 27 squared. Go ahead and type that in my calculator. 30 squared minus 27 squared gives me 171, and I need to take the square root of 171 to find this other side. Gives me a decimal. Okay? So we can say right now that BC is approximately 13 units. okay? If you so choose, which right now for our purposes, we're going to go ahead and go 3 places past the decimal point. So we'll say 13.07, and then it would round, that 6 would round to a 7. And that's the way that we would leave our answer for the time being, is 3 digits past the decimal point. Looking on to number 3. Now we're talking about angles, okay? So first things first, what do we know about angles? We know that all 4 angles are right angles. So I'm going to go ahead and talk about that. We know all 4 angles are right angles. So 90 minus 27 would give me 63. So this must be 63 degrees. The way that the angles are broke up, they should break up the same. We know that we have alternate interior angles. So this would have to be 27 down here, which would make this 63. All right? So here's where, looking at it, we can talk about it this way. We know we have isosceles triangles, okay? We know that all 4 pieces of our diagonal are congruent, which means that the base angles are also congruent. Probably the easiest way to explain that. Okay, we know the base angles are congruent, which tells me I can mark these other pieces as well. So now we should hopefully have all the angles we need. Let's look through it. MJK. MJK would be 90 degrees. And then we've got MJL. MJL is 63 degrees. JLK. JLK is 63 degrees. KML. KML would be 27 degrees. MNL. MNL. Well, there's 180 degrees in a triangle. Minus 27 and 27 is 54. My 2 base angles add up to 54. So we'll do the math here and say 126 has to be my vertex angle of that isosceles triangle. This time, please take a second, pause the video, and give number 4 a try. Welcome back. Talking about number 4. First thing I'm going to do when I look at it, I see right now, before I do anything else, that I have a pair of vertical angles, and I know I have a linear pair, which 180 minus 64 would give me 116 at each of these vertexes for my triangles. That's the first step I'm going to see. Now, looking further, this is going to use the same trick. We know we've got isosceles triangles because all 4 pieces of the diagonal are congruent, right? Congruent diagonals, which are bisected by each other, make 4 congruent pieces, which allows me to set up my triangles. I'd say 116 out of 180 degrees. I'm going to subtract it, and I'm going to say that is 64 degrees left. That would make sense. So my 2 base angles of my isosceles triangle would have to add up to 64. When I divide by 2, that means that I've got 32 degrees in each of those angles. This would be a congruent triangle, so those would be 32 degrees as well. Okay, working the same concept. Not sure if you noticed, but 180 minus 116 gave me 64. So 180 minus 64 should give me 116 for my triangle. That's our exterior angle theorem. Angle Z and angle Y for this would add up to 116. Because we know they're congruent, 116 divided by 2 would tell me 58 degrees for each of these angles. Likewise, their alternate interior angles on the top can be labeled the same. So as I'm looking at that, measure of x, w, y, x, w, y would be 58 degrees. Y, x, z. Y, x, z would be 32 degrees. Again, notice I'm tracing with my pencil to find these. W, V, Z. W, V, Z would be 116. X, W, Z. X, W, Z would be 90 degrees. And then X, Z, Y. X, Z, Y would be 58 degrees. So at this time, if you take just a minute, look down at number 5 on your own. See if you can figure out number 5. Welcome back. Let's look at number 5 together. Looking at number 5, the first thing I'm going to do is label DB is 42. In order to label that, I'm actually going to cheat a little bit, and I'm going to label each piece as 21. Because our diagonals bisect each other, I can label each piece as 21. It's a little bit cleaner when I'm looking at my picture. I know that AD is 26. And I know that DAE is 52 degrees. Okay? Based on what we've already done, I can say that this angle is 52, this angle is 52, and this angle is 52 based on the last 2 examples. Should be able to see that. That's our alternate interior angles based on our parallel lines. Okay? The next step for me, I'm going to say that all my angles add up to 90. So minus the 52 degrees is going to tell me that each angle is 38. Those missing pieces are 38 degrees, each of them. Okay. By rule, we know that our diagonals are congruent and bisect. So if this is 21 and 21, I could write 21 here, and I could write 21 here. And this is just knowing what I know. This is me just putting down on paper what I know. I know AD and BC are opposite sides, so they're congruent. So I'm going to write down my 26 right there. Okay, now let's go see how much of this information we've already figured out. We've said that AC has to be 42. We've said that EB needs to be 21. We said that BC is 26. We said that AB, well, we haven't been able to find that yet. We'll use Pythagorean's theorem in a minute. So looking on, ADC would be the whole angle. That'd be 90 degrees. ABD would be 38 degrees. BCA would be 52 degrees. And DEC, we still need to find. So let's start out looking for DEC. DEC is right there. There's 180 degrees in my triangle. I'm going to go ahead and outline the triangle for you real quick. There's my triangle. So 180 degrees minus the 76 degrees puts me at 104. Okay, so DEC would be 104 degrees. Looking on at AB. AB is this side length. Okay, so I'm going to switch colors on you one more time. And I'm actually going to go to a bolder color. As I'm looking at this, I'm going to say that AB is what I'm looking for. So I'm going to take this triangle right here, and I'm going to use my Pythagorean's theorem. I know A is 26. I'm looking for B, and I know C is that diagonal. They already told me is 42. So as I'm doing that, I'm going to come over here. I'm going to say 26 squared plus B squared equals 42 squared, or B squared equals 42 squared minus 26 squared. So as I look down, I can take my calculator and say 42 squared minus 26 squared. Take the square root of that number, and we'd say that it is approximately 33 or 32.985. 32.985 degrees. This has been Coach Eichner's Math. I appreciate you watching and look forward to talk to you soon.